In this video, we're going to simplify some of these division problems using our various rules that we had from the previous video, including simplifying radicals and re-representing fractional radicals. So our choice whether we want to keep something in one radical or two separate radicals with division is our over thing. Our most important concept is, can I reduce the two things under the radicals? Can I reduce x to the 8th over x to the 3rd? My second and my lesser thing is, can I simplify? Can I use one of these rules, basically when I get the exponent to match the coefficient, and simplify it down to just a variable or just a number? In this case, I can definitely, if I have them as a single fraction, I can reduce x to the 8th over x to the 3rd. And thankfully, this is very easy. 8 minus 3, using the rules of division with variables, I can rewrite this as radical x to the 5th. So that's the first part. So we can continue this. So like I talked about on the other video, I'm going to use this rule here to split up x to the 5th into two products, into blank times blank, giving me x to the 5th, so that one of them is a multiple of the index of 2. So if I count down from 5, 4, 3, 2, 1, 4 is the advantageous one that's a multiple. So I want to break this down into x to the 4th times x, both under their separate radicals. And then this one, the x to the 4th under the radical, can be broken down. Again, 4 is a multiple of 2. What I am doing is I am dividing the numerator, the exponent, by the index. So I'm dividing 4 by 2. That gives me x squared, and then the other radical x stays. So my final answer is x squared radical x. On the second problem, you're going to notice a pattern. I set this up so that it can be written much easier as a single fraction. 400 divided by 100 is manageable. That gives me radical 4. And again, everyone should know radical 4 is equal to 2. But just to show you, I can write this as 2 squared. The exponent cancels with the radical, giving me a 2. Now, it doesn't have to be a perfect division. It could be just like a fraction that can be reducible. I have the same index, gives me permission to rewrite this as a single radical. So the 3rd root of 27 over 18. And now I can reduce 27 and 18 to be 3 over 2 under the same cube root. And I successfully reduced it down to an easier problem. Now, this is not your final answer. This is a correct answer, but it is not the final answer. It's not the simplified radical form. So I'm going to split this back up. Cube root of 3 over the cube root of 2. With radicals, for a final answer, we do not like, so we prefer not to have any type of radical in the bottom. Well, I know that the only thing that, well, what I would love, I should say first, what I would love is if I could get something to the 3rd power, because I have an index of 3, and I could say that that's just equal to that. So what I would love to do is I would love to multiply this by 2 to the 2nd power under a cube root, so that I could, again, when I'm multiplying these, give me 2 to the 3rd power. To keep this legal, I have to rewrite this as a form of 1. So I have to rewrite 2 squared, cube root of 2 squared, over the cube root of 2 squared, which is again equivalent to 1. And then actually multiply top and bottom. So cube root 3 times 2. Again, I'm using a play off of this rule here, that a times b can be written this, or I could just write this as an actual product. So this is the cube root of 6 at the numerator and the cube root. Shoot. Well, so I made a mistake. It is not the cube root of 6 at the top. So hopefully you caught on that this is 2 squared and not just plain old 2. So 2 squared in this case, I could think of as 4. 4 times 3 is 12. So I'm going to go a little bit off track because I made an error. Down at the bottom, I want to keep them as base 2. I want to keep them as 2 to the first times 2 squared is 2 cubed. The motivation for that is I'm going to use this rule right here, that the power of 3 with the index of 3. So at the denominator, the power cancels the radical, so I have just a 2 at the bottom, and I have a cube root of 12 at the top. I could have left it as 3 times 2 squared, but I decided not to because there were manageable numbers. That's my opinion. And then I get a final answer right here. There's no coefficient on the numerator, so I have no opportunity to reduce with the 2, so I'm completely happy with this answer.